water of 10 centimeter diameter of the water is given moving with a velocity of 20 meters per second. Strike a stationary plate. Find the force on the plate when the plate is normal to the jet. Force on the plate we have to find out. If we take it as plate and it is jet. So we know the formula F is equal to rho A V square by G. Rho is density of water 1000, pi by 4 d square, d is 0.1 square in terms of meters, 20 square velocity, and G is 9.81, that is equal to 320.2 kg. 320.2, option B is correct. The kinematic indeterminacy of the figure shown below. So it is a hinge and 3 roller supports. The kinematic indeterminacy is of 7. Option D is correct.
Area between the arch enclosed by the curves, x is equal to a times of theta minus sin theta, and y is equals to a times of 1 minus cos theta between the horizontal. Now, if I draw the arch, it will look something like this, and x vary from 0 to 2 pi a, and we'll differentiate, we'll integrate the area between these limits. So area will be 0 to 2 pi a, whereas x varies from 0 to 2 pi a, y times of dx. Now here x is equal to 0 to 2 pi a, and value of y is nothing but a times of 1 minus cos theta into dx. Dx is nothing but a times of 1 minus cos theta d theta. If you integrate it, 2a square times of 0 to pi 1 minus cos theta square d theta. This will come around 8a square 0 to pi sin power 4 theta by 2. We'll use the formula of 1 minus cos theta, which is 2 sin square theta by 2. And let us use the formula to simplify this. It will be nothing but 4 3 into 2 1 into pi by 2. And if you are using this reduction formula, it has to be theta. So we'll take theta by 2 as some x, and there will be no change in the limits and so on. You'll get the answer as 8a square into 4 by 3 into 1 by 2 into pi by 2, which will be nothing but 3 pi a square. That is option A. Directional derivative of a maximum magnitude of a function phi is given as 64, which is parallel to z-axis, and you have to find the values of the constants a, b, and c. Now let us calculate v phi first. V phi is nothing but I times of dou by dou x plus j times of dou by dou y plus k times of dou by dou z into the function. Function is ax square y square plus byz plus c z square x cube. It will be equals to 4a plus 3c times of I plus 4a minus b times of j plus 2b minus 2c times of k at 1, 2, minus 1. Now, the maximum value of the directional derivative is given as 64, which is parallel to z-axis. If it is parallel to z-axis, there will be no x and I and j terms. So they have to be 0. So 4a plus 3c must be equal to 0, and 4a minus b must be also equals to 0. And the maximum derivative will be 2b minus 2c, which is given as 64. If we solve these equations 1, 2, and 3, we'll get the values of a, b, c as 6, 24, and minus 8, which is find the values of a and b, where limit extends to 0, x times of 1 plus a cos x minus b sin x by x cube is given as 1, a finite value. So let us use L'Hospital rule, because the given function is in the form of 0 by 0. So if we use L'Hospital rule and differentiate numerator and denominator, it will be limit extends to 0, x into differentiation of 1 plus a cos x is nothing but minus a sin x plus 1 plus a cos x, and differentiation of x is 1 minus differentiation of sin x is nothing but cos x by 3x square. Now the value of this limit is given as 1, that means a finite value. Now this limit will be a finite value if numerator is also 0. The reason is, if the numerator is 0 and denominator is always 0, then we can use L'Hospital rule so that we can go ahead one more time. We can go for differentiation one more time. So let us take the numerator as 0 at x is equal to 0. So if I take that as 0, then the equation will be 1 plus a minus b equals to 0, which will give you a minus b equals to minus 1. That will be some equation 1. To make this 3x square as a constant, we have to differentiate 2 more times. If I differentiate this function 2 more times, then the limit will be limit extends to 0, b minus 2a times of cos x minus a times of cos x minus sin x by 6. If I substitute x as 0, then the equation will be b minus 3a by 6, and this limit is given as 1. Now if I simplify, it will be b minus 3a is equals to 6. Let it be some equation 2. If I solve equation 1 and 2, then we'll get the values of a and b as minus 5 by 2 and minus 3 by 2, which is nothing but option D. Question is sin hz is equals to I, and we have to find the root of this equation. Now we know sin z as e power z minus e power minus z by 2. Now if I simplify, this will become e power z, e power 2z minus 2i into e power z minus 1 is equals to 0. Now we'll find the value of e power z by factorization. Now e power z will be nothing but I. That implies z will be log I. Now z is nothing but log I. This log I is nothing but 2i n pi plus log I, as it will repeat. It will be a periodic function, so we can take 2i n pi plus log I. 2i n pi. If I write this I in terms of Euler formula, it can be written as e power I pi by 2. This can be written as 2i n pi plus I pi by 2, which is nothing but I times of 2n plus 1 by 2 into pi, which is nothing but option A.